Now let's take a look at some examples where we're given graphs and points on those graphs, and we need to come up with the specific equation to describe that particular graph. So we'll start with this fairly simplistic situation. First, we identify the type of function. We can see that it's a line. It's a linear function. And on what interval or intervals is the function increasing or decreasing? Well, it's decreasing across its entire domain. And since it's linear, it isn't concave up or concave down. From your experience, describe something in the real world that a function of this shape could model. Well, if we took money out of our bank account at a specific amount every week to donate to charity, we could see how our bank account would drop along a linear model. Now, to find the particular equation, we're going to take the same approach for each of these examples. We're going to start by using the general equation for the particular function. So in this case, my general equation for a linear function is y equals ax plus b. Now, we're given points on the function, and we're going to use those points, plug them into our general equation, and solve for our unknowns. Since the unknowns we have in this equation are a and b, we're going to need 2 points to come up with 2 equations to solve this system of equations. So we'll start with the 2 points that are given, 5, 19, and 10, 6. Our first equation, we'll plug in 19 for y and get a times 5 plus b. And we'll plug in 6 for y and get a times 10 plus b. Now, for linear systems of equations, we have 2 ways to solve, either elimination or substitution. I'm going to use elimination here, and I'm going to subtract the second equation from the first. So 19 minus 6 gives me 13. 5a minus 10a gives me negative 5a, and b minus b eliminates the b variable. So that tells me that a is 13 over negative 5, or negative 13 fifths. I'm going to use that information and go back and substitute into one of my 2 equations. I'm going to use the first equation, so 19 is going to equal negative 13 over 5, substituting for a, times 5, plus b. So that tells me that 19 is equal to negative 13 plus b. So b is equal to 32. That tells me that my final equation then for this line is y equals negative 13 fifths, my value for a, times x plus 32.